go to step 4. Else, go to ... Okay, so we'll figure out the ... later on. So now we are at step 4. So step 4 in this case is f prime of x equals 2x, because we want to reverse that operation. Okay, then we apply the substitution operation. Okay, so the substitution operation is this. You say post 43 equals the substitution operation applied to pre 43, and then we specify what are we trying to find in pre 43. Okay, we're trying to find occurrences of x here. And what do we want to replace it with? We want to replace occurrences of x with f prime applied to x. Let me say that again, and this is all going into the screen recording, so if you watch the screen recording again, you will actually get this part too. Let me just say again what this means. We are trying to perform a substitution operation. Whenever you want to do a substitution operation or replacement, if you will, you need 3 things. You need to specify 3 things. What is the original item? In this case, the original item is pre-43, which is already given to us. I don't have to ask why that is the case. The second thing you have to specify is what are we finding in the original thing? And the third item is what are we replacing that with? In this case, we're replacing that with f prime of x. Is that okay? How I specify the substitution operation. Okay. So we'll go ahead and perform the substitution operation. But before I perform the actual substitution operation, I would expand pre-43 first. So basically, just copy and paste f prime, which is just simply 2x. That. Is that step okay? All I did was to expand pre-43 and f prime of x. Okay. And then I just go ahead and carry out the operation. X is greater than z has a reference to x. I replace that with 2x. Y does not refer to x, that's fine. K does not mention x, so that's fine too. So that's my solution. Okay, post 43 is going to be 2x is greater than z and y is different from k. Is that okay so far? Okay. So now we want to try another example. Let's try line 71. Line 71 says x is initialized to 0. Okay. So we go ahead and repeat some of these steps here. We go to step 1. Does the right-hand side refer to the left-hand side? No, 0 as an expression does not refer to x. So we cannot go to step 2. Step 2 is still the same step 2 as above. So in this case, we have to go to another step that we have not mentioned yet. So we have to go to step, say, 5. Okay? What do you think step 5 is going to do? Step 5 is actually the easy one. We have to use what I call a forget operation. Okay? So we say apply the forget operation. So in this case, the post condition of line 71 is going to be based on the forget operation applied to pre-71. And what are we forgetting? We're forgetting anything that mentions x. Okay? So we have to specify x here to basically say we are forgetting components that include any mentioning of x. But at the same time, we can add some more thing to it. We can say x does equal to 0 at this point. So don't forget the conjunction. Do not forget the and x equals to 0. And that is outside of the forget operation. Because we take the precondition first and say there are certain things we can no longer keep in the precondition. And that's the forget operation. But once we have processed the precondition, we can also add and say, oh, but by the way, we know that x does equal to 0 at this point. Is that making sense? Yep, go ahead.
Yeah, are you using the forget operation the same way as you were using
substitution?
the forget function?
Yes. Did we talk about the forget already last time?
Yes.
Okay, it's the same thing, but this time I'm
But
using a very
you're
mechanical
you're
method.
still making sense.
Yep, okay. Yep, go ahead.
We're using forget because we're trying to debug what happened at line 71, or kind of, why are we using forget right now?
We are using forget because, okay, I forgot to say one thing, given you are given that pre-71 has to be something. So in this case, I will just make up something. So x is greater than, or x is different from 100, and y is less than x, and z does not equal to y. Okay? Go ahead, ask that question again.
Okay, we're using forget operation because we're debugging, trying to figure out what went wrong at line 71? Is that
No, we're not debugging, we're moving forward. So we're trying to go from the precondition to the postcondition in this case. Okay? So since we are given the pre-71 is like that, we are going to copy and paste this into the forget operation. And what do you think the precondition will become after the forget operation? This part mentions x, so it cannot be guaranteed anymore. Okay? Well, actually it can, but in this case it's a specific case. And I will show you why, it is also okay not to have forgotten that part too. The second part, y is less than x, can we keep that part? No, because there's no way to tell what x was before other than it is not 100. Can we keep this part? Yeah, we can keep that part. Okay, so what we can do now is to keep the part that mentions x, z is different from y, but also add the fact that x does equal to 0. And that's the solution. So if I want to complete my instructions here, this will be step 5, step5, and the same thing over here. If the right-hand side refers to the left-hand side, but there's no inverse function, you still go to step 5. Okay. Any questions at this point? Yep.
I want to clarify in my mind. You did line 71 to explain your forget function.
When to apply the forget function.
Right.
Yep.
But everything else above was the step-by-step of
That's
the
for using the
function.
substitution operation.
Right.
Yep.
I'm having a hard time understanding why we're using the substitute operation and the forget operation. What are we trying to achieve?
We are trying to understand the behavior of a program, or we're trying to understand, given that this condition is true before a certain line, can we say anything about several lines down? What do we know at that line? Okay, so we will see how we can chain these things together too. Yep. Yep. Okay. Okay. So do we have any questions at this point? Yep.
What do you mean when you say the right-hand side refers to the left-hand side?
The right-hand side is an expression. So in this case, the right-hand side of the assignment, operation. So it's the right-hand side of the assignment and the left-hand side of the arrow, if you will. So it's the right-hand side of the arrow and the left-hand side of the arrow.
So what if the right-hand side is constant number?
Is
The constant number.
then it does not refer to the left-hand side. Yeah. Any other questions? No questions?
Constant number, it doesn't refer to the left-hand side.
Well, because a constant is not x, right? If you look at this one here,
Right?
does that mention x?
No. Oh,
No.
I see what you mean.
Yep. So in this case, the right-hand side does not refer to the left-hand side.
Basically, both sides have to show the same variable.
Yep. The right-hand side has to refer to the left-hand side to have a chance of applying the substitution rule. Because even if the right-hand side refers to the left-hand side, there's no guarantee that that function is reversible. Because I can have 0 times x, 0 times anything is 0, so it is not reversible anymore. So in that case, even though it is 0 times x, which mentions x on the left-hand side, the function itself is still not reversible, and as a result, I still have to use the forget rule instead of the substitution rule.
I have one more question.
Mhm. Mm-hmm.
I thought it was saying that you're trying to forget that x equaled something previously in like pre-71, and so it equals 0 in this case.
Mm-hmm.
So why did you take out the y is less than x when it...
I cannot guarantee
Wouldn't
that
it be
anymore.
y is less than 0?
No, because we don't know. Because I can give you one example. The precondition, which is x is different from 100 and y is less than x and z is different from y, there are many combinations of x, y, and z that can generate this, that can make this condition true, right? I can make x 101, y 100, and z to be 103. Okay, that will satisfy that requirement already, right? Once I reset x to 0, is y still less than x? No.
No.
Not true anymore, because remember y is what, 101 or 102? Okay, 100, y is 100. 100 is not less than x or less than 0, so that's why I can no longer guarantee this condition. If there's something I cannot guarantee anymore, I have to take it out of the precondition when I make my postcondition. Okay, the most important point that you have to remember is the precondition is a guaranteed condition before line 71 executes. But at the same time, post 71 is a condition that is also guaranteed after line 71 executes. So if there is a chance that it may not be true anymore, you have to take it out.
And will that usually only happen with the forget?
Hmm?
Will that usually only happen with the forget?
The forget is the only way to take out components. The substitution one does not take out components. It just modifies the precondition to become the postcondition. The forget operation, on the other hand, will basically get rid of components in the precondition when you come up with the postcondition. But it does add one more thing, so don't forget about the last part here. Because of the assignment statement, we know for sure that x does equal to 0 at that point. Okay. So are there any questions at this point about assignment statements, how to compute the postcondition from a precondition, but only using assignment statements? Is that okay? All right. If that is okay, then we'll go on and move on to conditional statements, which is a little bit more interesting. Okay, so we'll go ahead and, yep, go ahead.
I just had a quick question. When will we use substitution? When will we use forget? If the left-hand side refers to the right-hand
Right.
side?
We go through these steps. We go to step 1, we ask the question, and depending on the answer of that question, we either go to step 2 or we go to step 5. We go to step 2 and we go to step 3. When you go to step 3, there's also a chance to go to step 5, because if the function has no inverse function, we still have to go to step 5. And step 4 and step 5 are basically final steps. They tell you exactly what you have to do at that point. Okay, and I should probably add in step 3. Okay, if an inverse exists, prove it, then go to step 4. Okay, because we want to make sure that what you think is an inverse function is in fact an inverse function. Because sometimes we look at a function and we say, oh, the inverse function is blah blah blah, but as it turns out, it is not. Okay, so you have to double check and make sure that your inverse function is in fact the actual inverse function. Okay. All right. So let's just move on to conditional statements. Conditional statements are interesting because we have seen it already, but to calculate the postcondition from a precondition gets a little tricky. So we'll use something that we have seen